Hey, it's Luke with OOD Darts. Today we are going to do a full build guide on the Infinite Pack. This is one of my favorite designs that I have ever got to put together, and I'm really excited after almost 5 years of not having it on the shop to finally be re-releasing it. This is a high power feed system, and all this Infinite Pack is designed to do is to feed balls really, really fast out of this tube. This pack can be put into a backpack or on a pack. You can use a variety of different containers. We have different rings to allow you to connect any kind of container you want. The whole system runs off of a 3S LiPo, and it can feed 20 rounds per second continuously. The way I designed the Infinite Pack is 2 parts. First, it's got a very high power brushless motor driven fan over here. This produces very high volume air and high pressure. And then it's got an auger that actually agitates and aligns the balls properly to get out of this outlet fast enough. We have a brand new PCB designed by my buddy James. He's our contract engineer, does some work for us. The board enables one key feature, and that's current sensing. And what that allows you to do is have a power connector coming out of the pack and connecting to your blaster, and then your blaster is powered by the pack. Not only is the blaster powered by the pack, but then the current sensing on the board allows the pack to turn on both the blower and the auger motor all at the same time while you rev. So when you rev, you're firing up everything all at once, and there's no additional wiring, meaning that all you have to run to your blaster is this 2-wire connector, which goes directly into your battery terminal. There's no additional circuitry required. Makes it really, really easy. For those that were around for the first version, we did make some changes on this board. Most notably, we've removed the little pots on here that you had to adjust. You no longer need to adjust them. We found that very few people were actually using that. Now, if you want to adjust anything, you can do it in software, and for those that are familiar with Arduino, one of the easiest programming languages out there that's so accessible, you'll be able to download code and you can update this with USB-C if you like. Now, if you do change the code, you're doing so at your own risk for the entire system, so please keep that in mind. We've tested our code and that's kind of where we are at, but you do have that option and we will provide the code for anybody that wants it. One other feature we added, which was much requested, was an on-off switch. So this is a high amperage switch and it's master on-off. It sits below flush here, so you can set this down and it won't be able to turn on. Warning here, however, if you have this externally on your pack, people are definitely going to do this when you're playing, and it will probably be annoying. Sorry. All jokes aside though, for safety reasons, it is important to have an external on-off switch. We thought that was necessary for this round. Now, if you're following this build guide, this is v4.0, so keep in mind if you're looking at an older version or possibly a newer version, just make sure you're watching the same video. As always, if you have any questions, just email us and ask, orders@outofdarts.com. Lastly, this uses an unprotected LiPo battery, and LiPo batteries, that's lithium polymer batteries, can be extremely dangerous. You'll get one of these cards attached, but please read all documentation, read our website, check out our videos there. There's more information. LiPo batteries do have specific care and management procedures. I'm not going to go over all of that now, but this is not exhaustive. You absolutely need to read up on this and get savvy if you're going to be operating these batteries. As always, we try to make these build guides as easy to follow as possible, filming across multiple weeks with different parts. If you see parts disappear or reappear, it's okay. As long as you follow step by step, you should have a functioning assembled Infinite Pack by the end. Next, let's talk about the tools you're going to need for the build. You're going to want some super lube or lubricant, some thread lock of any type, usually blue is going to be the best for this, a standard screwdriver, though in this case I'm probably going to use a driver frequently, an 8mm wrench or an 8mm socket. This is for tightening the blower fan, a 2.5mm hex driver. I'm going to use the powered version. You'll need some solder. I always use lead-free, especially in the shop here. You'll need eye protection, a soldering iron, a pair of helping hands, a heat gun, although you can get away with just using the tip of your soldering iron to heat shrink, an X-Acto knife in case there's any little bits of cleanup or 3D printed material you need to move. A set of wire strippers is really handy. Not totally necessary. You can get by with the X-Acto knife if you like. A pair of snips or flush cutters, and a pair of pliers. If you are going to use a powered tool like this for any of the various implements, make sure you've got one that's got torque limiting. I love this little Black & Decker as it gets down really low on the torque and you can actually stop it with your fingers. Without further ado, let's get right into the build. First, we're going to start with our body here and we're going to install our brushless motor. One thing I want you to check before you're starting is make sure that there are 4 brass inserts in the base. There may be a 5th one here, ignore it, it's unused. And you want to check that these holes are all clear on the top here and here. If they're not, just take an X-Acto from the bottom and just clean up any little bits of plastic. We do clean these up in the warehouse, but just in case they get to you and need anything else, pretty simple. So first we're gonna take this motor, we're gonna unthread this. Note that it is threaded backwards, so it's counterclockwise to tighten. This sits in here like that. We're just going to thread this through this small hole right here. So all three of those go through, and they will pop out the back here. As always, it's more difficult on camera than it is in front of you. And then we'll set that kind of right down in there, and those 4 holes should line up in the back. You'll want to support this while you're working on it, or we'll leave it turned over for now. But we're going to use a little bit of Loctite on every single one because this motor has a ton of torque, pretty high RPM, and ultimately when it's got that brushless blower on there, there's a lot of resistance. So we want to make sure it has as much power as possible. Now you can use your included Allen key, which we give you in the kit, but I'm going to switch to this driver right away. This stuff's plastic safe, so it's no big deal, but you really only need a drop on each. And then you're just going to drive that all the way in. I like to go about not completely tight all the way. That way I can get them all in, make sure it's centered, and you're just going to repeat 3 more times for the other ones. After you've got all 4 of those in, you can double check that they are all fully tightened. You don't want to over tighten them, but they should be snug. Next, we're going to take these 3 wires and we're going to feed them down through this tiny little piece of plastic here that keeps them in place. Now you are going to want to know the order, in order that they came out of the motor. Right out of the motor, you can see they sort of split off nice and evenly. So I like to put them through one at a time and kind of separate them. So here's the one that's farthest that direction. Here's the middle one. And then the last one I'll just pull. And you can pull these all the way through, but the main thing is you want to be able to identify what's what later. If it helps you to differentiate, you can use permanent markers or paint pens to color 2 or 3 of these wires. Alternatively, you can also use pieces of tape. Just be aware of which colors are which. Next, we're going to install our gear motor, and this is the power of the system that actually moves the balls around and agitates them properly to get into their place. This is an offset motor, so you may have to kind of twist it as it goes in, but the holes should line up. And then we need to get 1 screw in first to hold it in place. Do note that if you set this on your surface, you've got the motor tabs here, so be careful. It can damage a surface too. Just a little bit of Loctite or thread locker. Then after we've got 1, we can use the base plate kind of as a caddy to hold on to this, and just watch that those wires are tucked out of the way. But now we've got that, it makes working on this a little bit easier. And just repeat for the other 5 screws. Now we've got all 6 screws threaded in with Loctite, and we're ready to go to place on the fan blade. Your fan blade will look like this. If you have a little tab in here, you're just going to break that off, and if you see any little extra bit of plastic or anything that's kind of loose, you can trim that off. Or take an X-Acto knife if you see any little bits of loose filament. Yours shouldn't need this, but just in case it does, it's nice to show you on camera here. Now that we've got that ready, we're going to look at this motor itself, and you can see that there are little indentations. These indentations will line up with these little notches that I've built on the actual blower fan. It's really important to get this seated straight, so there's a witness mark that just looks like a little bit of a dirty notch on the edge here, and there's 1 on either side, and that actually corresponds to those notches, making it a little easier to line up with 2 of these tabs here. Hopefully that makes sense, but you'll feel it if it doesn't go all the way in. You'll feel it kind of pop down in, and then we're going to take our screw here, and the screw is kind of also an identifier. It'll tell us if we're not deep enough. I'll go ahead and use the same tool that you might have, which is a standard wrench. It's an 8mm wrench. I'm just going to hold this with a couple fingers, so I'm just stopping that from turning. You don't want to put too much force on 1 single blade, but as long as you spread it out, you will be just fine. Note, while you are tightening this, it is lefty-tighty because it's reverse threaded. And you should feel this kind of almost feel like a little bit of a grinding as it goes down because it's got little teeth on the bottom of the nut itself. You don't want to go too tight, but you do want that snug. 2 fingers should be able to stop this. You shouldn't go any more force than that. And then when you are done, and you look across here, you should see about 1mm of the red sticking out of the top of here. If you do not see the red sticking out of the top, then your fan is not all the way down. Then you give that a little spin, make sure that is working. This is the powerhouse of the air feed system. Next, we're going to install the fan cover. Now, the fan cover has a couple different configurations. The most simple is just putting it right on here, taking 2 of your 10mm screws and screwing them right here and right here. They thread into the brass inserts below. That's fine as long as your pack is not going to be contained inside a backpack or hidden from something or locked away from air, because this is the inlet. So all of your fan capacity goes in here and then comes out the hole after it goes through the pack itself. But the way I most commonly set it up is with what I call a snorkel, and it's another part assembly that we're going to put together right now. The way this works is this actually goes on top of here, and it holds a piece of leftover tubing that comes with your pack. Because the pack comes with 4 feet and you really only need about 3, so you're gonna end up with a foot, maybe 6 inches, and that's just enough to put on as a snorkel that you then stick this outside of your backpack if you're enclosing the whole thing. So to do this, first we have to sort of uncover the hidden holes here. So you'll notice there's actually 2 holes that are partially covered here, and they can really easily be trimmed out to be used. After we've done that, take 20mm screws and you'll shove them up through the bottom like so, and then you're going to take this piece here, and the wider portion should face up. This will be pretty obvious because you can see that it needs to cradle the actual hose right here. And then after that, you'll put the top piece here. But before you do that, you're going to want to take a piece of your hose. Now, if you're not sure how long this is going to be, you can hold off and do this at the end, but I know that I only am going to need about 8 inches of this or 6 inches of this, so I'm just going to make a quick cut. This one's not as crucial to have it cut as cleanly. When we ship them to you, we do try to cut the ends as cleanly as possible to make it as easy to install. But then essentially there are these nice little grooves here. They're going to lock this into place, and we're going to put that on like so. And then we'll just go ahead and screw that together. This does not have any rotational relief, but it shouldn't need it because essentially all you're going to do is have that stick out the side of your pack so you can get that fresh air. Next, we'll go ahead and we'll actually install this. Again, if you weren't doing the snorkel, it's the same procedure, just 2 screws from the top, 10mm, no thread lock on these. Next, we're going to install our auger. These come installed with brass inserts. We've already installed them for you because we have done this enough times that it saves anybody any issues there. So you'll take 2 20mm screws and you will put a little bit of thread locker on here, and that's just going to catch that brass insert and help hold it. You can actually put a little bit more than a drop, just enough to get it all over the entire length of the screw. I got a little bit too much there, but you just kind of want it down most of the length. And then we're going to go ahead and pre-thread this. So I just barely see it there. It's pretty much at the point where the screw's going to bottom out due to the design. And then same deal here. This is basically just counter support on the other, so they push against each other against the shaft of the motor itself. So there I can see it peeking out. I don't know if that shows up very well on camera, but I will back it out so that it's not in the way. Next, we're going to look for the flat side here. And it's the same side that says brass 20mm. That is your flat side to match up with this motor shaft. So as long as you line those up, you should be able to feel that go down, and you should feel a click. And if you look down in here and you feel down below, the edges of this auger should be almost touching down below. There's about 2mm of space between the bottom of this and the bottom of the auger. So the auger and the base of this area. So if you've done that, you're then good to tighten them. Should only be a couple turns. And I like to do the flat side first, come back to the other side, which is under here, and then go back to the flat side again to check. There we go. Again, if you're using one of these tools, don't use the short end. You can put too much torque on there. Or if you do it sparingly, because you can rip screw heads right off with an L wrench like that. Now you can go ahead and set this aside for now. You won't need the base for a little bit. And we're going to flip this over, and this is going to be our work surface. If you can do anything to stabilize this as far as how it sits, that can be really helpful, whether that's putting a weight on here or supporting underneath with something. I just happen to have this little gauge thingy, which is just not really for this, but I'm going to put that under there because it makes it much more stable. You'll also want your helping hands for this section, and we are going to start with our PCB. So this is a custom circuit board we had designed. I have an engineer I work with, James. Huge shout out to him for all the work he's done with this. We're going to put it in this configuration. So everything should face back this way as far as the soldering terminals. And you want this to be relatively level when you solder. So when you're doing the first joint, you want to try to keep it as level with the base plate as possible. Don't forget to put on your eye protection. And if you haven't already, this would be a good time to heat up your soldering iron. Now we're going to start with the positive and negative terminals that solder directly to your motor. As long as you have this in the right configuration, you're good to go here. Now you do not need to fill up the entire cup, but you are trying to heat that little circle until you get a nice flux. Hold the board in place with your other 2 fingers. You want to make sure it fluxes fully. There is a lot of copper in this board, and you want to let that fully cool before you move your fingers or the board or anything else. And then repeat for the second terminal. Again, you don't have to fill up the whole terminal. We've seen some people like just absolutely saturate this. If a third of it is connected or half of it is connected, that's more than enough electrical contact for the distance. And it should just look like that. Now we're going to install our ESC. I flipped this around just because I like working from this angle when I'm working on the ESC. We have these 3 wires, and you do need to, again, figure out which was going from top to bottom, 1, 2, and 3. Because once this is installed, it's going to be 1, 2, and 3. But before we do that, we're gonna go ahead and install the ESC power. Now when the ESC is installed and everything, it'll be all the way in this compartment like that. So I like to drop it in that compartment, and then I like to shorten up these wires. So I'm only gonna make these wires as long as they need to be to reach that terminal. And again, positive is always labeled on all of these and negative is the unlabeled. You definitely wanna make sure you get all of those right and don't swap any of the connectors. Then you can strip the end of this. You can either use wire strippers like these, you can use an X-Acto knife, or if you've got the right length fingernails, I've gotten pretty comfortable doing that for whatever reason. So once we kind of got that position in here, we'll go ahead and give this a little bit of a twist. And you want to insert that about halfway down into the hole. And if it helps, now that you've got this, you can take the ESC back out. Now you can clamp a helping hands on the wires back here to hold this in place, but I tend to, when building the proton pack, just use the wire terminals to hold for the most part, except for the ESC motor leads. Now every single solder point on here, you want to keep this as flush as possible, so it can help to put a little pressure down. It looks like that's actually doing pretty well. But same way we did the inside one, we're going to apply heat to the wire, get the solder going in there. You're trying to heat the wire, the solder, and the solder pad all at the same time. All right, that's looking pretty good. Now you could cut this and shorten it because it's much longer than it needs to be, but it doesn't hurt anything as long as it doesn't get in our way. So what I'm gonna do is just give it a couple wraps around there just so it sits out of our way. You could also tie a gentle knot in it and make sure that the black goes to ground. That's the top pin there, and the other, that's the signal. And then you're gonna push that all the way up. If you feel like this is too loose, you can either pinch the two connectors together just slightly so you get a little more force, or you can put a little dab of hot glue there too. Either would work just fine. Now is a time when helping hands are super useful. Don't clamp on the board itself. You want to clamp back on the wires, preferably. And we are going to solder to terminals 1, 2, and 3, as I'm labeling them, to 1, 2, and 3. So the top, middle, and bottom. Top, middle, bottom. You have to have this side facing up for that line up to work. Now this is the middle. I'm kind of just tracing back to double check. You really don't want to have to solder these twice. That I found is the top. I'm kind of checking back, so I'll start with that one. Before you start soldering the ESC, cut off 3 sort of 15 centimeter pieces, maybe a ½ inch or so. They don't have to be very long, but you want 3 small pieces of heat shrink to cover up these terminals that we're going to solder. Put 1 on each. That way it's ready to go. It's a good habit, but it's just anytime you cut a wire or have an exposed wire, throw a piece on it, because even if you don't use it, it's there if you do need it. All right, so I'm going to solder the first terminal. I've got that nice and flush there. Again, it's the same idea. We're trying to heat everything at the same time. You should have a nice glossy bead, kind of a matte finish as it dries, and then we'll repeat for the other 2. I've determined that this is my middle wire. For anybody watching closely, I had to resolder that first terminal because I forgot the heat shrink the first time around. Never looks as pretty the second go. And lastly, the bottom terminal. Now we're going to wait to heat shrink these connections until our final system test because the board needs to be powered on before the ESC can work. Now we're going to install our switch, so I'm going to flip that over like this, and I prefer to put it so that the terminals are further away from the board, which is further in that direction. So it should look just like this when you put it in. We're only going to use 1/2 of this switch, this side over here. So we'll go ahead and you just want to kind of work this down. It'll be tight, but it's a snap fit and requires no glue. Next, you're going to want to set your packs up like this. You kind of got this piece here raised up. It's at the same level of this. This will make this as easy as possible and get us the cleanest wire routing overall. One quality of life bonus that we've actually included with this that we never included in the first are pre-wired connectors. So this is the 5-foot cable that goes to the blaster. It's wired on both ends. It's just done and ready to go. You don't even have to make this anymore. The other is for the blaster connection, and that one is also good to go. Now the last one is a pre-wired connector, but this one we do need to extend because it was for the previous generation, but again, I look at it as kind of a perk because we're adding extra. So you will have a spare section of wire like this. So the first thing we're going to do is we're just going to extend this one. These pre-wired connectors do have solder on them. They are tinned, but I'm going to go ahead and clip them off because I want the flexibility to be able to insert them. So again, we're going to strip again, give that a little bit of a twist. Then we'll take our extra spare bit of wire, we'll strip that. And again, if you were using the real tool, you could of course do that too. We're going to take about an inch, 1.5 inch of the heat shrink, and we're going to put that on our red wire. And this is all in service of giving us a master on-off switch. If you didn't want a master on-off switch, you could just connect these directly, positive, negative, just like that, and you'd be done. So I put that piece of heat shrink on there, and we're just going to prep these two so that the 2 pieces of wire are facing each other. I'm going to go ahead and put a decent amount of solder on those to pre-tin both connections. Anybody's new to soldering, this is like the best way to practice, is just connect 2 wires. After we do that, we'll put them as close as we can to each other, and then we'll go ahead and solder them together. Anytime you're doing this, you also want to check the back of the wire, make sure it fluxed all the way through, and mine's looking good on both sides. And then we'll slide that piece of heat shrink up while it's still hot. Let that heat get most of the work done for us, and heat shrink the rest. So we're making you do a tiny bit of extra work there, but we're saving you on these 4 other connectors that you don't have to do at all. Next, we're gonna go ahead and take this black end of this cable, we're gonna put it into the battery negative. And again, we want that flush and lying down as best possible. And this one can be pointing this way because the battery is gonna stick off this direction. Then we'll take this and we're gonna tuck this underneath all of these other wires. And it's gonna run kind of underneath the board. And that will go over to our connection here. There are gonna be 4 wires running this way, and they're all going to kind of coil around as you close up the pack. So running them exactly where they need to be makes life a lot easier later. Now we'll go ahead and solder both of those in. I'll do this one first. We've done 4 of these connections already, so this is our 5th on the board. There we go. And then we'll do this connector. Now note, when you're working with these connectors here, the first thing is we don't want that to sit too far up. We kind of want it to come out the back. And when you're soldering these, note that this is just a ABS shell, so you want to be careful with the heat that you don't apply too much. Try to apply most of it to the wire rather than to the terminal, but you will apply some to the terminal to flux it and hold everything together. You do want to make sure it fluxes fully. If it doesn't, you can have one that's actually stuck on the terminal but won't have a good electrical connection. It can just move around. So after that's completely cooled, I like to just check by giving it a little tug. If anything moves, then you know you haven't done it quite right. Next, we'll take another piece of the red 14 gauge and we're gonna put it into our battery positive. And this one, we're gonna slide underneath the board. Just gonna try cable manage as much as we can as we go along, and we're gonna run that up and through. This just ensures that it stays out of our way when we're closing things. Then we'll go ahead and solder that point right there. Next, we'll take this wire, and this is going to end up in this other terminal here. So in order to do that, we're going to cut it a little bit short, make sure that it comes down from the side. Again, give that a little twist. You want to be really careful that none of these contacts have any chance to cut. Should you find that you stuck too much wire in there, you can go ahead and just clip off the tip. I'm actually going to do that because there's a little more wire sticking off that first connection than I want. So I have just cut that a little shorter to make sure that there's no chance of these two touching. You can technically add heat shrink here. I might actually try. Sometimes at the angle here, it's a little annoying because I'm not coming in from the top like you would want to. We kind of want to come in from the sides due to the space inside the enclosure. And then we'll repeat just like we did before. As I said, if you want to try, wouldn't hurt to get a piece of heat shrink in here, but I'm gonna have a hard time getting it into the position it needs to be in. Yeah, technically it would go over and onto those terminals, but I'm gonna leave it like that. That is just fine. Now, one thing to check before you go any further is just make sure that these 2 wires in their current configuration, you can play with the slack down here as needed, but this should turn and twist on, and you should have nothing getting in the way of the screw holes. You can see how that kind of just guides around, and it should fit really well. Now we're going to go ahead and install our XT60U, the mountable connector with that screw I just dropped. Put it right in here, and it should fit just slightly hidden there, like that. And then you're going to take your 2 screws, which are normal Phillips screws, and you're going to drive those until it's nice and tight. Like everything else, this doesn't need to be overly tight. It's just securing that connector. Now we'll take these 2 wires coming from the blaster out, and if you have room to slide them underneath the board, depending on your wiring down there, if you leave too much of a tail on any of these connections sticking down into there, it can get in your way, so something to keep in mind. So for mine, I'm just gonna run them right here, kind of in between, but the idea is all 4 of these wires will end up together. And like I did last time, I'm gonna go ahead and snip the ends off of this just because they're not quite as flexible and bendy as I'd like them, and they're just getting in my way. Then we'll go ahead and solder those 2 points. And with that, we are essentially done with soldering. It looks like a little bit of a jumble, but all these wires will follow around as you close, and then when you want to open and service, you can set this down on a surface like this. If you ever have to open it for any reason, you have tons of room to play. It's worth mentioning there's nothing to adjust here, so you basically don't have to touch this ever again unless you are going to go into Arduino and change the code. Just know that you're doing so at your own risk when you're changing settings. Next, we're going to attach a hose. Now, you only want to cut one end to start. Look at it carefully and try to choose the end that is the cleanest because it'll make the best connection. Now, we are going to use some super lube, and the super lube is only there to help ensure an extra airtight seal. The only place you need to put that is in this little crevice. You're just going to fill kind of this crevice and this little bump right here. And that's just gonna help us retain as much air pressure as possible to give you the maximum performance as far as feeding goes. Now, this has been designed down to the millimeter here. If you've got the right end that we pre-cut, this should be nice and clean. And you're going to just put this on like here, and then you're gonna want 2 of your 10mm screws again. Put the other side on here. Try to keep the hose straight while you're doing this. And on these ones, you don't need to go extremely tight, just snug. And then you'll want to give that a few turns, just kind of move it around, make sure it moves fine. You should be able to extend this tube all the way forward, and then with your hand at the other end, you should be able to rotate this freely. It is a pretty snug connection, so this shouldn't be very, very loose because we do need that to be relatively airtight like the rest of the system. If you have any issues with it being too tight, you can just kind of squeeze on it and really just work it in. I usually give that a few rotations with that lube in there to make sure that that is all good to go. Next, we're going to do our battery door, which is very simple. We're just going to take the battery door itself and a thumb screw, which is also a new upgrade on this system, and just check that it all fits. There's a brass insert inside that catches it, and you just screw that in. Should be 4 or 5 turns to tighten, and you're good to go there. When you want to remove it, just unscrew it, and you're going to kind of pull on it a little bit to grab the door itself. Next, we're going to do our cable run. So this is a pre-soldered connector. It's about 5 feet in length, and all you're going to do is plug that in down here. Make sure that seats fully. I like to give it a nice little pigtail there so it can rotate around. So I'll start about there, and then we just grab these clips and every so often clip them on and hold these in place. You do have the option to pull these through. It's not tight enough that it stops it later, so you will be able to change it if you need to later. I put these typically about every 6 to 8 inches. You can space them out however you like. We more or less include spares because you don't really need all 10. All right, and there we have it. That tube is dressed, and I have a few spares left over just in case. Before we close up the blaster, I want to mention one thing, and that is the fan direction. This fan needs to rotate in this orientation, which from the top down is clockwise. You want to think of where the air is going through this little channel right here. All you need to do is power up your blaster and pulse your blaster and just watch it spin down. Do not stick your fingers in here because this is very sharp. You can hurt yourself if you were doing that. This is the one time that will activate the fan while it's open. Now, if it is not spinning in this direction, all you need to do to swap the rotation is swap any 2 of these wires. I'd recommend the 2 right in front. Just put the bottom one to the middle and the middle one to the bottom, and that will take the 3-phase motor and reverse the direction. Great, we can go ahead and heat shrink. We're just gonna slide the heat shrink on each one all the way up as far as we can get that in there. Try to hold it as far that direction towards this end as possible, and then we'll take our heat gun and just cinch those up. You can also do this with the back of your soldering iron. Now that that's cooled and we've got our heat shrink on there, we're gonna go ahead and insert this back down in here. So you want most of the wiring to end up down over in this cavity rather than underneath the board, because you want this board to sit low enough and flush enough. So you can kind of just loop it around and gently coax it back down in here. Be real careful if you are using like a metal tool like I am now. Really the better tool would be like a ballpoint pen or something soft. Great. And then once that's in there, try not to force anything, but that's approximately how it should all look. You want this channel here to be completely clear because there's a lip that goes in there, and then you want that to be clear. Now we'll go ahead and put on our container. Now we are pre-gluing these. These are just hot glued on, but we have a big drill jig that we drill these out at the warehouse. We also offer all kinds of other plates if you want to use your own container. We have a flat plate, we have a plate like this. Essentially, these just have embedded square nuts here, and you're going to take 2 of your M3 by 8mm screws, and you're just going to thread them most of the way in so that they're not peeking out of those holes quite yet. Then, knowing that you're going to ultimately end up in this hole here, as far as those screws, you're gonna go just slightly off, it's about 1 inch, and you're just gonna do a tiny turn, and from there, you can tighten these and they're good to go. And if that sticks out into the container a little bit, that's totally fine. This container's a little beat up. You can see it was actually Infinite Pack number 2 from the Mark Grober Crunch Labs project. That was pretty fun. We had 4 of these guys going. And with that, you essentially have a built pack. The last thing to do is tighten up your base, but I like to do that after I've actually wired it up to a battery and tested. So we're gonna do that really quick first. Now we did have one odd thing with the code here is that the ESC doesn't arm on the first startup chime. It'll wait a few seconds and it'll do it again. So we'll hear it here. Normally you would leave your switch in the off position, but it doesn't matter much. So plug in, remember that you've got an on-off, so you turn it on. You'll hear one attempt to arm. It'll wait about 5-6 seconds and then it'll arm. Those chimes are the ESC getting signal from the Arduino so that it's set up and ready to go. So we should be good now. One thing I will show you on another pack here really quick is that this here is for custom projects where you just want to activate it. If you bridge these two terminals together, just with any switch or wire, it will activate the pack. So if you ever had a need where you want to manually activate the pack, but not use the current sensing that the actual unit itself has, that's something to consider. But since we have a blaster here, I'm gonna go ahead and connect this to a blaster. This blaster has no battery in it, of course. We've taken it out and it's simply bridged to here because now the battery in the Infinite Pack also powers the Juno or whatever other 3S blaster you're gonna do. So with any luck, we should have blower going and auger going when I rev this motor. That's looking pretty good. Our last assembly step is to take 4 of the 20mm screws, and we're just going to screw them in to secure the base to the top. It's worth noting you can fill this container all the way up. Don't pack it all the way to the top where the lid is pushing down. You can get the balls actually trapped. Just pack it to the lower of the rim and you'll be safe there. And it's about 420 rounds, 430 rounds with the hose capacity as well. You have to have the lid completely closed, so I have closed that lid. And now I'm just gonna hold this on here manually because I don't have the adapter handy at the moment, but let's go see how much of a mess I can make. All right, and there we have it. That is your completed Infinite Pack. While this pack can dump repeatedly over and over and over, and it can certainly handle the abuse, most of the blasters cannot take several thousand rounds going through tiny flywheel motors consecutively. Even this Juno, which is a great blaster, if you go play with this in a real situation, it'll work great, but if you try to dump this container 3-4 times in a row, I wouldn't recommend doing more than a single container before letting this cool down. But realistically, it's designed for active play, these blasters are, and even the stock rival blasters like the Percy's. If you're going to use one of those, we don't recommend dumping multiple packs in a row because the flywheel motors just get too hot and they just can't keep up with this feed machine beast. If you have any questions, as always, reach out, orders at Out of Darts, or leave them down in the comments. Thank you so much for watching, and until next time, I'm Out of Darts.